All right, for chapter two, this is called Evaluating Nutritional Information. And we're going to focus in this video on the first section, which kind of looks at how we get, how scientists, food scientists, nutritional scientists, dietitians get nutritional information. And of course, we're going to start by looking at a few things about the scientific method. If you've had a kind of a general bio class recently, or even a high school class, I'm sure you've talked about the scientific method, and we're going to see how it applies here to the area of nutrition. In general, we said in the last chapter that the science of nutrition is kind of a dynamic science. There is new research coming on the scene all the time, and it's really been in the last, I don't know, a couple of decades that they've really turned to an area of scientific study of things like nutrition and dietary practices versus some of these other areas like intuition or common sense or conventional wisdom, just tradition or personal reports. That's called anecdotes. In other words, if you think back, about how you learned about some things, some aspects about nutrition, maybe it was a little about intuition. Maybe it's just kind of a gut feeling that we know that, we shouldn't eat too much chocolate cake or it's going to cause us to gain a little weight, or that's kind of common sense also. Or maybe, in times past, we learned from traditional methods. We learned from nutritional habits from our parents or grandparents or great-grandparents, or even personal reports that we've heard from other individuals. Now, there's nothing wrong with each of these or any of these categories, but in general, now nutritional experts, they basically have a scientific approach to getting the scientific data for nutrition and dietary practices that we see now. So this is more evidence-based, right? So they're actually doing scientific studies to try to look at, well, is there a link between our diet and like cardiovascular disease? Is there a link between, eating carbohydrates, too many carbohydrates and gaining weight, or carbohydrates and the onset of diabetes? All these types of things. This is more scientific evidence-based research rather than just, tradition or personal anecdotes. So I wanted to go over this first section in the textbook. Goes kind of quickly. We'll kind of look at the steps of the scientific method. Most of you have seen this before, but if you haven't, we'll kind of go through these kind of individually. In general, the first step, whether it's a basic biology textbook or here for nutrition, the first step of the scientific method is always, well, let's look at some observations. What's going on in a particular problem you're trying to address or question that you want to answer. Let's just get some general observations. You could have any kind of example you want to here, but if you think about, well, is there a connection between eating lots of fatty foods or having a diet and high cholesterol? Is there truly a connection between that and the onset of cardiovascular problems, heart disease or heart stroke or blockages in the vessels or something like that? Is there a connection there? That could be just some observations that you start with. With that initial observations, that's when you start to formulate some type of hypothesis. And most of us have heard of how a hypothesis is an educated guess or an educated explanation for the observations that you just saw. It is educated. In other words, you're not just randomly providing an explanation. You're using those observations that you just generated to start thinking about the situation or the problem or the condition you're looking at, and to try to formulate some type of educated explanation to explain those events. Step three is to do a little homework, is to kind of review what's already known about that particular question you're trying to address, because it may be that somebody else has done a similar study or has some information that goes with what you're looking at, and so it's always good to review the current scientific literature that's available. Once that's been completed, then the researchers would design some type of a study, and many times that includes some type of testing certain populations. We're going to talk about different observational studies and some information there. performing those types of tests and then collecting the data. And that's your experiment portion here. So step 4 is kind of this experimental design and conducting those experiments. 5 is to try to analyze all that data and see if there's any conclusions that can be drawn from those results. So again, if you kind of follow with the example of fatty foods and cholesterol, you may design a study where you're looking at populations that have a high fat diet, and to see if there's any onset of any type of cardiovascular problems, or compare that with another group that has a very low fat diet or something. Look at the numbers, look at the data, see if you can draw any conclusions from that. That kind of ends your study for step 5. And then so part 6 or step 6 here is to share that information. And so what researchers would do is they would take that information, they would submit it to some type of scientific journal. Usually that journal is going to have a group of individuals that have been set up as peer reviewers. They're going to review that information there. It will get published. And then step 7 is maybe there's, maybe by answering some questions that leads to other questions. And maybe there's more research that needs to be looked at in order to kind of follow up on what you found in that initial study. Take a look at these kind of vocabulary words, and many of these you've seen before. Again, if you've seen scientific method in other classes, but again, we're looking at the scientific method is really all about evidence. It's about collecting data based on a particular experimental design, looking at the evidence and seeing what that evidence is telling you about your original hypothesis. That's different than just an anecdote. Anecdote may be, just a personal experience that somebody's had. A lot of times you'll see this, and we'll see this in the second section, but a lot of times you see this if you look at a dietary supplement. A lot of times you'll see a dietary supplement and you'll have, an anecdote from a person or a reviewer that said, hey, the supplement worked great for me. I took the supplement, I was able to lose 20 pounds in a week or whatever. They give you all this information there. But that's just their personal experience, and it doesn't necessarily mean that particular supplement will do the same for every individual that takes it. That's more of an anecdote type of an analysis versus an evidence-based. All right. For each scientific study, you'll generally find a treatment group. And so that's the population that you're studying, that you're kind of testing and receiving a particular treatment. It may be a drug trial. It could be a pharmaceutical study that they're looking at a particular drug for diabetes or some type of cancer or some type of heart-related problem. And they give them that particular medicine that they're trying to look at. They're always going to have a control group. Remember, a control group is basically there for comparison. You want to look at your experimental group or your treatment group, compare that with a control group that doesn't receive any kind of a treatment, that doesn't receive that particular medicine. That's where many times you would have, if it's a drug trial, they would give that individual what they refer to as a placebo. In other words, they don't realize it's not a drug. It's just a placebo, basically a fake treatment, or something that doesn't interfere with their overall physiology. And then there's always going to be at least one or maybe more variables that are studied. Usually it's a single variable, but some type of variable that may change, that they're looking to see what impact that treatment has on a particular variable that they're looking at. When you look at human studies, human research, you probably have seen this word before, especially if you think about epidemic, a widespread health condition in a population. That's what we call epidemic. And so the study of any kind of widespread health problem usually is called epidemiology. And so that involves looking at, well, where is this occurring? What populations is it affecting? How widely distributed it is? Usually it's referred to some kind of health problem. It could be disease, infectious disease related. It could be a virus study or a bacterial study or contamination, something like that. Or it could be looking at a particular diet and to see how that particular diet affects different conditions or different individuals. During the course, we're going to look at several examples of diets. You may have heard of some of these, such as the keto diet or the ketogenic diet. We'll look at something called the Mediterranean diet, DASH diet. There's probably hundreds of different diets out there. But if they're studying the diets and kind of how they affect individuals, it could be more of a health issue for epidemiology. It could be the onset of cancer and what conditions may cause or lead to a particular type of cancer or diabetes or just a number of different health issues. Usually these are observational, what we call observational type studies. And generally you think of these as either a case control type study. In other words, this is where you have you're looking at individuals in a population that have a particular health condition. You compare that with similar individuals with similar characteristics and backgrounds and demographics. You compare that don't have a condition. So you kind of have an experimental group here that have a particular health condition. Maybe it's cardiovascular problem, right? They've had some kind of heart-related disease or something. And then you look at that population. Maybe you're looking at the onset of cardiovascular disease in middle-aged females. You can do that, and then you compare that with the same group of individuals or similar group of individuals, so middle-aged females that don't have that particular heart condition, right? And so that's a case-controlled study. A lot of times, though, you're going to see observational studies that are a cohort study. I don't know if this is necessarily more common, but you do see this quite often. A cohort is just kind of a fancy way of saying this is a large group of people that you're kind of tracking data on over time. The time just depends on what type of study you're doing. It may be a year, it could be 5 years, 10 years, 20 years, 30 years. You're tracking a population, kind of keeping up with a population over a defined time period. That's a cohort study, right? And so you can think of cohort studies as either prospective. The word prospective means to look forward. We're looking forward in time. Or it could be a retrospective cohort study. That means to look backward in time. So let's look at a prospective scenario. So let's say you follow a group of healthy individuals. You pick a population that you're interested in studying, the scientists would. They're looking at a particular group of individuals. They're completely healthy for whatever known thing that they're looking for. And then they kind of track them over a period of time. That's the cohort part of this. They look at this over a particular time to see if anything changes in their overall health and to see what kind of lifestyle that they led. Maybe it's a 10-year study, and you look at that group of individuals over 10 years. They initially are healthy. After 10 years has passed, you analyze them, you kind of look at them, look at your data, and you could say, well, what things, maybe out of those 10 years, after that 10 years, maybe half of them develop some type of cardiovascular problem. And then you can say, well, what led, is there any indication of what, lifestyle or dietary choices that they had over that period of 10 years that may have contributed to the onset of, whatever heart condition or whatever variable you're looking at? That's prospective. You're looking forward. Looking backward, this is a different type of a cohort study. It's you're basically getting a group of individuals. And in this case, you're starting here with this group of individuals. These would be individuals that have a particular health issue. The example in your textbook says, okay, this group of individuals that you're studying all have some type of stomach cancer. And then you look back in time and say, well, could we pinpoint any factors that this cohort had, this group of people in this population had, that may have contributed to the onset of stomach cancer? Maybe there was a large percentage that had a lot of tobacco products. They smoked a lot, and that led to that cancer. Or maybe it's their dietary factors, or maybe it was working conditions, or overall health conditions, or pollutants, or whatever the case is. But you start with a group of individuals that have a particular health issue. You look kind of back in time to see, is there any reason or anything that could have influenced their overall health that would have caused that particular health issue. Any kind of study generally has certain types of limitations. Epidemiological studies have kind of their own type of limitations, and what generally is, and we've probably all seen this before if you've looked at any kind of study before, but in general, epidemiological studies can show kind of a relationship, what we call a correlation. They can show a correlation, but a lot of times it's very difficult to establish an actual cause. So your textbook kind of gives us a couple of examples to look at. One of the questions it mentions is, well, does increasing the amount of sugar-sweetened soft drinks in our diet, does that lead to obesity? And so, again, for this type of a study, and I'll show you a couple of examples here, but for this type of a study, if the only variables you're looking at, and basically you have two variables here, you're looking at increasing sugar-sweetened soft drinks in someone's diet and weight change. And so could you say that there is a direct cause and effect of individuals that had more soft drinks would lead to obesity? That may be an underlying factor, but could you definitively say that was the cause? You see, that's kind of the problem, because you could say, well, what if it was, there are other health conditions? Maybe it wasn't the drinking the soft drinks, maybe it was a metabolic issue, or maybe they weren't exercising at all. Maybe they were physically inactive. Maybe not only were they drinking soft drinks, they had a particular diet that led to problems with weight and obesity. So again, this isn't really establishing the cause of the problem, but it could have some impact or correlation. And so here's correlation defined. It's just a relationship between variables. And you see that whenever you're looking at least two variables, generally two variables, and they seem to change over that period that you're looking at that study. The diagram of the figure here from the textbook, it's kind of looking at that same example I just mentioned on the sugar soft drinks in the population. And so the idea is they would have a cohort type study. This is a group of population here. They look at them over 10 years, or they kind of study this for 10 years. They look at the population results at the end. And they're looking at two variables and seeing how they change over time. One variable is how much sugar sweetened soft drinks that's part of their diet. The other variable to look at is, how did that impact their overall weight? And so in this particular study, they found at the very beginning that 4 out of 5 individuals initially looked at had healthy weight, but after 10 years, 4 out of 5 of those individuals tested had a weight that was kind of in the overweight category. In other words, in this case, they recognized the correlation was that as you increased soft drinks, sugar-sweetened soft drinks, weight also increased. So in this case, both variables went the same direction. Both variables increased same direction. They went up. And so that's called a direct correlation. Sometimes you see this referred to as a positive correlation, although you don't see this as much because a lot of times we think when we see the word positive, we think this is good, or we see the word negative, we think bad. but it doesn't necessarily mean good or bad. Positive in this case means it's going in the same direction. So a lot of times you'll see this referred to as a direct correlation, both variables changing in the same direction. It could be an inverse correlation or a negative correlation. And again, it's not necessarily bad. It's just that in an inverse relationship here, the variables, two variables are changing in opposite direction. They have a different example here. In this figure, you got two different one population here you looked at for 10 years. And you have a number of individuals that were diagnosed at this initial time with hypertension, high blood pressure. They followed them for 10 years and they found out that as the population increased like fruits and vegetables in their diet, they saw a decrease of hypertension. They saw a decrease in high blood pressure. And again, this is a correlation. It doesn't necessarily mean that if you eat your fruit every day, you're going to have less hypertension or less, lower blood pressure, because there may be other factors involved. This is only looking at this, these particular variables, but there was a correlation. Now, and again, this would have been an inverse or negative correlation in this case because these variables are moving in opposite direction, right? So they increased fruit over the 10 years, but they saw a decrease in the onset of high blood pressure. So that's why this is being inverse or negative correlation. All right, so I hope this helps kind of get us started with chapter 2. We'll have a second video for the second main part for chapter 2 to kind of finish this out. Thanks, guys.